Hi guys, how are you? Well, in this topic, in this video, we are gonna take how to calculate a transmission by chain. So I prepared these two examples that I recommend because it have some traps in the text. So let's start. Well, the equation is I'm gonna explain it little by little. So let's start with this. Let me show you this. A machine which works with moderately impulsive loads have a principle of movement additioned by electric motor and a gearbox of conical gears, and also have a secondary movement actionated since the principal shaft by a chain transmission. Remember this secondary movement. Well, I, secondary movement actually since the principal shaft by a chain transmission. What does it mean? That the chain transmission is in the secondary movement. That's simple. And also with this, a machine which works with moderately impulsive loads. We are gonna use this information. So now in some data of the system, we have an electric motor with frequent starts, a gearbox with a radio of 4, principal shaft speed 300 rpm, principal shaft power 10 kilowatt, efficiency of the principal movement 90%, and the same by the secondary is secondary shaft power 4 kilowatt, secondary shaft speed 100 rpm, and efficiency of the secondary movement 90%. So let's start with the example. Remember this, the principal movement is the principal electric motor, so it's the principal speed, so we should start with 300 rpm. So okay, I put this of how if you don't remember how to calculate the radio, so it's an example of different ways you can use it. Now we have the secondary movement that we have 100 rpm, so it's a driving, so we have a radio of 3. Remember, because that transmission by chain is in the secondary movement, so that's the reason why we are using 100. That's the reason why we are not using the gearbox, because here we have a gearbox transmission, and the secondary movement we have the chain transmission, so that's the reason why we put in black this letter, this part. So we have a radio of 3. Well, you can calculate, but what I put in this case for check the board, because if you read, we don't have any information that tell us of the number of teeth of the sprocket, so we shall to use the notes. Well, this note is in Spanish. I'm gonna translate in English if you want. I'm gonna presume if you know Spanish, you can learn it. Something that said, well, the first part it's not totally. It's more for design in drawings. But let me talk about the secondary. In the case of secondary, the rule tells you if the change is gonna work in high speed or it's involved in impulsive loads, the sprocket so should have a minimum of 25 teeth and should be treated by heat thermal treatment. But another said, if you want a good operation, you should use a sprocket with a minimum of 19 teeth. So remember, this is if you want a good operation, the minimum of 19 teeth. But if you have a high speed and some impulsive load, you should have a minimum of 25. So in this case, I'm gonna reduce it. In this case, we don't have a high speed because look that speed, but also we don't have a really shock pulse like this or impulsive loads, so we have moderately impulsive load. not impulsive load. It's different. So we are gonna use 19 because it's the minimum for good operation in chain transmission. So if we have a radio of 3 or 19th of the sprocket teeth, so just multiply. But it's something, it's here. That's the reason why I put checkboard, because we have that word of for sprocket. If we have a 19 teeth drive sprocket and a radio of 3, so we have a driving sprocket of the driving of 57. Well, in this case, it's because the radio it's a number of how can I say it? It's a exact number. But if we have decimal, I don't know, 2.2.5, I don't know, you know it. So we are gonna check that table, because maybe if you have 3.5, so you're not gonna use 47. You are gonna use 76, because it's the rule to use this number for good operation. So in this case, because it's 3 and 3 it's in the board, so that you use 47. Now it's the application factor that we have also board F1. This is F1. This is also in Spanish, but I'm gonna do the English version. But I'm gonna translate. Pay attention, please. This is something for characteristic for the machine movement, and this is the characteristic of the propeller of the the who begin the movement. This is a smooth operation. This is a slightly impulse, and this is moderate impulse. We are here. This is an example for a smooth operation. Tell us of electric motors, turbines of steam and gas turbines. These have that's the combustion motors, of the cars. And we have some accumulation with hydraulic. For slightly impulse, we have some of the combustion motors of 6 or more cylinders. Sorry, I don't remember this. With like the couple that when you need when you use the electric motor with the pump, that's part of when that the assembly is the acoplate, I think. The electric motors with some frequent start, and here for moderate impulse we have the combustion motor of 6 more cylinders with that mechanic union. In the characteristic of the machine that we are gonna move, we have a smooth operation. We have a smooth operation, the moderate impulse, and high intensity impulse. An example for this is we have the pumps, centrifugal pumps and compressors, some print machines, some conveyors with uniform loads, stairs, some for mixed liquids, fans. For immediate impulse, we have some pumps and compressor of 3 cylinders or more. We have some conveyors, but with no uniform loads. We have some mixes of solid mixes. And for high impulsive, we have some like mining machines, presses, guillotines, pumps, and compressor for more cylinders. So in this case we should do a match. So you know, we have a machine which works with model impulse load, okay, and electric motor, the principal electric motor with frequency start. So the propeller, does it mean, is the principal electric motor with some frequent starts. That means in this. So we are in this column, and then we have a machine that works with model impulsive load. So we are here, and as you can see, it's we are in the middle, so we have to do a match. So we are here, and in this case we have 1.5, so we are gonna put 1.5. Okay. In the case of F2, we have the teeth factor, and it's the same. You have an equation, but you can see this equation it's by F2. In this case, we have a 19 of the sprocket teeth, so that's the reason why F2 should be 1. But something that you should remember, this is in Spanish also, but the most important thing is if you select a sprocket with less diameter, so this is gonna reduce your capacity to transmit that power for the chain. So in this case is 19, so 1. The requirement power is in this case for it's a data, but be extremely slowly, I don't know how to say it, because we have the chain transmission in the secondary movement, so we should use 4 kilowatt, not 10. If you put 10 of the calculate, it's gonna be bad. So we have 4 here. The efficiency, that it's also data, it's the 90%. So how you calculate this power, the power that we are gonna need for your transmission? Well, in this case is the requirement power. In this case, because efficiency, you have to divide with efficiency, and all these we should multiply by the F1, this application factor, by the teeth factor, and it's gonna give you the power of the transmission. So now with this data you should go by the table. What does it mean? You should 6.67 and a sprocket speed with this, you're gonna enter with the sprocket speed of 300 RPM. So we are gonna use this table. You can ask me if you want this table, all this information I can give you if you just put in the comments your email, or I don't know, your LinkedIn, you know, something to send you the information. So this table, I don't have this table in English, but maybe you can search it. This is for Renault. But what I want to tell you, you have 3 in this case for this table. For ISO norm, you should simple doublets, triplets. So what doublets is that you have a chain of 2 columns. Triplets is 3 columns. It's like more heavy. So we have the 300 RPM, so we are in this place. We should select the 6.70 or what, 6.67, sorry, 300. And for simple we are gonna do for the 3 cases. For simple, try to search 6.67, so maybe in this, and 300 was 300, this line. So I'm using my finger in this moving forward, so we are like this in this case. Okay, so we are maybe in the middle like this. So we should select, if you be very carefully, you can interpolate, but in this case, because it's the video, we are using the quick click method. So 60.6 like this. We are here. We are in the intersection like this. So what does it did this line mean? So we have 19.05 millibars of the step phase, by the each part of the chain. We have that 19. Oh well, in this case we have it. So we have the step of the chain, and now we should calculate the center distance of the system, well, of the your sprocket and driving. So we have a recommendation, if you don't know it, of you can use the 30 times the well, in this case it's a step, or 15 times. You have this range. So if you don't know, you can use just in the middle 40. So that's we put here 40. Okay, if you don't know, you are collecting, you are doing a calculate. I'm gonna give you some example more for in this case, but first let's finish this, and then you are gonna calculate and approximately the all how can I say it, eslabones, how can I say it, links, well okay, how many links that your chain is gonna have. So this, we have this equation. I'm gonna put, because if you can see, if you want, if you can have a screenshot, you can use this now. So this is for the sprocket teeth, the driving teeth, the center distance that we have this for the system, the step of the phase, the steps, or by link. So that's the equation. So what this case, now we use this for calculate, as you know, but now we should calculate the real elongation, real longitude, I don't know, real distance of the chain. So what does it mean? If we have in this case 118.91, so we should do the immediate part number. So in this case is 120. This is the real. Well, if we have tensor, you can have a sprocket and a driving, but maybe you can have some tensors to maintain that tension in the chain. If you have it, you should plus 2. So what does it mean? 122 an example, but in this case example that doesn't give you this information. So if you don't say it, if you don't see this in the real life, so don't plus 2, and then you're gonna start to calculate the real center distance. Well, it's a variation of this equation, but if you have always me, this is the equation. You can take a screenshot if you want. V in this case is the step, so all the same. L in this case the real distance is 120. It's so simple, and you are gonna do the same for, in this case, of doublets or triplets. Let's gonna do it. For doublets, we have the second column. We have is the line of 300. This is the line of 300. So we have here for 6.67. It's maybe like this. So we are here. We are in the intersection a little, or maybe we can take the next one. So you have two options. I'm gonna take this example, because if you have this, maybe if you are here, a little bit higher but this line, so we should go the next one. So in this case is another, it's again, sorry, the 19.05. so we're gonna repeat it. We are gonna do the same. 40 in this 20, so it's the same. In the case if you, I'm sorry, if in the case if you have to do the for the triplets for the third column, so you're gonna have the 300, so this line, and search 6.67, maybe it's like here, so you should go for the next one and take, in this case it's 1587 millibards by step like this. So show you 55, sorry, yes, 55.87.5, okay. 15.87.5. So let's do the same 40. In this case, well, it's, if you know, if the calculate give you the same, or maybe a little bit the same number, well, it's something that the real center distance is different. So what you can do, just accept it. But I'm gonna give you the example because, so in this case you just calculate. You should, now you know what type of chain you are gonna need for, if you want a simple chain, doublet chain, or triplets. But in the case, well, in this part, recommendation, you have a range of 30 until 50 of the steps. But if you are designing a system, a transmission system by chain, pay attention. So if I tell you I want the less dimension that you can use, so you are gonna use 30. If I tell you if I want the less dimension, left distance maybe of the transmission, you can use 30. And the maximum, so it is another thing, it's 50. Okay, and now maybe you are gonna say, how can I know if I should use simple doublets or triplet chain? Well, in this case, you are the designer, you are the person who is selecting the chain, so you should have that, you should know for what you are gonna use it. If you want to improve your security of the system, maybe you are not gonna use the simple, you're gonna use the doublets or triplets, and it's gonna be okay because it's the system. If you know if that is gonna work better by security, you're gonna use it, and it's okay. And if I tell you if I want a more economy, the more cheap for the tree, it's obviously the simple. So it doesn't. So let's remember it. So the cheap chain or economy or more economy or comfortable, oh sorry, is the simple chain. To improve your security in the system, you can select the double, well in this case is doublets or triplets chain. And also what I tell you, yeah, for the less dimension, for less dimensions or short center distance, you should calculate with 30 times the step. Okay, never forget it, never forget all this information that I give you. Never. It's gonna be really important. Really, this is in the real life. This is information you use in the real life. So let's start with a second example. I use this second example because here it's there is a trap if you don't know how to read good. What does it mean? Here, calculate and determine the characteristic of a chain transmission to activate a pump system which is going to work with impulsive load. We have a V6 motor of 1800 RPM, the pump unit by 4 pumps of 45 kilowatt each one. Each one is in a 300 RPM, and the system efficiency of 97%. So let's do all the again. So we have in this case 100, so 1000 RPM. We have a 300 of the pumps, a radio in this case of 6, and let's show you this. I have a rate of 6. Okay, we are in the maximum, so I don't have information of the sprocket, but here said which is gonna work with impulsive load. We have impulsive load and 1800 RPM. It's yet something considerable, so we should use 25 feet. So remember the rule. If you know, you have. So theoretically we should use the 150 in this case feet, but you should maintain this rule because this is something that it's a norm, so it's by DIN norm. So we should use 114. We have 25. There isn't seats, but we have seats. But you should use for good transmission. If you wanna do a different design by your own, so you can put a 150. But if you don't know, you should maintain zeros. Don't not preoccupate or do not take this equation extremely that if I should multiply, maintain this because it's a recommendation. Then for the in this case of application factor F1, where we have a pump system, 4 pumps, we have some remember impulsive load. So we have combustion motor. Yes, we have a combustion motor. The propeller is the combustion motor, so we are here. We see it's more loads, but we don't have well, no, we have some impulsive load. So if we have impulsive load on a combustion motor, we are in this case 2. But if this is for just a combustion motor, and this is for more option, so we are here. And then also we have for pump system, so we are in the case of moderate impulse. We are in the pump system, no more. We are not in mining machine, so we should just the match and put 1.7. Oh, sorry, 1.7. So we are here 1.7. In the case of the teeth factor, we are for this case we have a 25, so 25, in this case it's 0.76. So we are here 0.76. The requirement power, pay attention please, this is the more important, because maybe you are thinking, oh yeah, pump unit by 4 or 45 or 4.5. okay, we are 0.5, and then all your calculate is gonna be bad, all because it's not 4.5. You have 4 pumps of 4.5. so what does it mean? It's 4 multiplied by 4.5. okay, that's because you should maintain the system. You should maintain the system of this. the power that you should enter here is the system power we have, because the motor is moving 4 pumps of 4.5 kilowatt, and all of this system is by a transmission chain by change. So you should put the power of the system. Never forget it. Pay attention really with this information can change all your design. The efficiency, let's continue, it's 0. Well, with this information you start do all the same. Imagine that I told you that I want the short distance and the more cheap or comfortable in price. So let's start with the simple. So we have a 23.8, we have a 23.8 of the potential and 100, let's see by here, and 1000, sorry, of let's think it's 2000, or maybe like this. We are here in this line, nearly this line, and we have 20, maybe I think it's by here. Okay, so we should go for the next one, and the next one is this line, and this line you should go, it's 19.05. and we have this, and I want a short distance, so we are not gonna use Fourier, we are gonna use Theory. And then it's all the same. If we have 136, well, in this case the next part number, in this case that's the real longitude that we need. Okay, and if you want a safer, more safe, sorry, if you want more safe chain, you can do the same calculate by doublets and triplets for these columns, and it's the same. Well guys, I hope you this video helped you a lot, like how to calculate in the real life transmission change, by change transmission. Maybe, I don't know, in the real life you don't have this information, that is more like impulsive load, something like this, I know. So that's where, and that's you, like an engineer or the apprenticeship, your, I don't know, an internship, you should try to do your own recommendation, because you are the designer. You should know where you are, and if you know, that's the reason why exists this table to help you to select if you don't know it. Sorry, this is gonna allow you to have a better design and a better calculation. Very carefully with the, when you read it, like over like case like this, very carefully. And if you have like some notes, you can add this, because it's the same. Oh, sorry, here is times. Okay, so thanks guys, have a nice day. I hope you are fine, and if you have any question, please do not hesitate to ask me, to put in your comments. If you want this information, just put your something in the comments. I want the information, the boards, your email, maybe, you know it. Thanks guys, have a nice day. See you later for the next video of belts.